Well, good morning, everybody, or good afternoon. So sorry we're not all together. This is the first day of class. Hopefully, both first and fourth period are watching this video. This is our YouTube video. Today's date is 8/31/2020. I sure wish I was with you guys. I do miss seeing you. So, here's the deal. Hopefully, you have had a Zoom meeting with me for my first period class. Fourth period class, we're going to do a Zoom tomorrow. So Zoom tomorrow for fourth period. When we go on our Zoom, we're going to take a look at our interactive notebook, rules, regulations, and we're also going to look at our student journal. Okay, so these are the parent functions we're looking at, and I talked a little bit about it in our Zoom meeting. But if we haven't, and you haven't seen it, let's go through this. So the objective today is really a transformation, which is basically moving. So it's a transformation, and hopefully you're taking notes and putting these notes in your interactive notebook, okay? Transformations of functions. Maybe I'll grab a different pen. Hold on, I don't like this pen. Okay. Transformation of functions. So let's figure out. Transformation is a word that means either to move or change. Okay, so let's just say change. So we're going to change. So the word transformation is basically a change, kind of like transformers. And a function is a fancy word for a graph. For right now, we'll have some graphs that are on functions. We'll talk about that later in the year. But anytime you see functions, we're talking about a graph. Transformations, we're talking about a change. You know, like transformers, like Bumblebee. So we have certain graphs we call our parent functions. Parent function. Okay, so let me grab a highlighter so I can highlight that parent function thing. So our parent functions are going to be like the basic function, and then we're going to move them or change them. Okay, so for example, f of x and y are the same thing. Just get in the habit that y and f of x mean the same thing. So let's change this to y and f of x are the same thing, and there's a reason we're going to talk about f of x later. So let's just say, call this y equals 1. Well, y equals 1, if this is the x and y axis, every value along this graph right here, the y value is 1. 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 So if I graph y equals 1, it's always going to be 1. Then the parent function is going to be this graph right here. Okay, that's my parent function. Okay. There it is. There's my y equals 1. It's a horizontal line at 1. Y is always 1. The y value is always 1. The y value is always 1. So that if you need g of x is -3, okay, so then I'm going to go down to -3. 1, 2, 3. And there it is. Okay. That is g of x equals -3. Remember, g of x, f of x, y of x, same thing for right now. Describe. So we just do use words. It's going to be a vertical shift down. Let's see, we went down 1, 2, 3, 4. Okay, that's just all we have to do is just use words for description. Okay. Okay. Example 2. Let's go back to y equals mx plus b. Hopefully you remember that, where b is the y-intercept, m is the slope. Okay, b is the y-intercept, b is y-intercept, and m is the slope. And hopefully remember the slope is rise over run. Okay, so if I have plain old fx equals x, fx equals x, well, the parent function then is this y equals, okay, this one right here, same thing, y equals some x, but let's call it a 1 over 1x plus 0. Now there's some invisible numbers, right? There's no 0 here, but I want a y-intercept, and there's no number 1 here, but I need a slope. So on the parent function, y equals x, start at 0, and I'm going to go then up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay? Okay, there we go. And then we'll just kind of go like that. That's our parent function. So that there is y equals x is my parent function, okay? Write that down, parent function. Call it a parent function because it's like the basic, most basic. All right. So now, if we're going to take and graph y equals 2x minus 4, let's make that a 2 over 1, and I'm going to do that in red, also different color. So I'm going to start at negative 4, because that's y-intercept. I'm going to go 1, 2, 3, 4, okay? And I'm going to go up 2 over 1, because it's going to be a slope of up 2 over 1, up 2 over 1, up 2 over 1, up 2. Hopefully, you guys remember how to do this. This is graphing lines. Hopefully you learned this in algebra. I hope so. You'd be bummed if you didn't know how to graph lines. But, you know, if you don't, that's how it is. Y-intercept, go down to negative 4, starting point. Slope of up 2 over 1, up 2 over 1, up 2 over. Okay, describe. So what happened is we took the parent function and we did a vertical shift down. So we did a vertical shift down, vertical shift down 4, right? 1, 2, 3, 4, down 4, and we made it twice as steep. So we did a stretch. So we also did a vertical stretch because it stretched instead of up 1 over 2, it stretched up to a vertical stretch of 2. That's my description. Just use words, okay? All right, now let's turn the page. So if you're taking notes, then that's what I want you to do is just take notes in your interactive notebook, which hopefully you have an interactive notebook, right? You do have a notebook. I like this one. I like the ones with the grid, so that's what we're doing. Is my interactive notebook. You're taking notes in that. Okay. That's why we need the Zoom meeting first, but hey, we'll make it work. Okay, so here we go. Fx equals, this is the absolute value. Absolute value function. Okay, so the absolute value function looks like this. For the parent function, it is going to be, hold on, get all my pens. Well, hold on, there it is. So I'm going to start at 0, 0. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, and then negative 1, absolute value negative 1 is a positive 1. Absolute value negative 2 is a positive 2. Absolute value negative 3 is a positive 3. So the absolute value graph looks like, it's like a V, because everything's going to be positive. So if you have negative values, they become positive, okay? You have negative values become positive. That's why it looks like this, okay? So that's our parent function, okay? Now, hopefully, you learned this last year. If you didn't, we're going to try and remind you. But we're going to take this graph right here, the parent function, and we're going to move it to the left 2, and then we're going to go up, up 3. Now, this has got to be always the opposite inside, because negative 2 will zero this out, okay? It's always, always, always in the inside. In the inside, it's always going to be the opposite of the inside. Okay, so let's see what we got. Let's take this graph, my parent function, let's move it back 2 and down 3. It goes right there. Okay, cool. There it is. And then let's graph that. So it's the exact same shape. I'm not going to make it any, I'm not going to do a stretch because there's no number in front. So I'm just going to go same graph. Here's my translated function. So I moved it, took my parent function, I moved it back 2, up 3. So description, well, what did we do? Just what I said. We did a horizontal shift left, 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 opposite left, 2, and we did a vertical shift up. Oh my goodness gracious, I made a mistake. Up 3. Oh, I did. Darn it. You know, if we were in class, somebody would say, Mr. Davies, you made a mistake. You said up 3. and I went down 3. Hold on. Holy moly. Let me find my whiteout and fix this. Even I make mistakes. It's early. I need more coffee probably. Something like that. Yeah, darn it. Shoot, I did make a mistake. I know. This thing, if we were in class, somebody right now would be saying, Mr. Davies, you said back 2 and up 3. 1, 2, 1, 2, 3. So it's going to be right there, isn't it? My bad. My bad. My bad. Okay, there it is. Fix it. Whew. Thank goodness for a whiteout. Or erasers. Okay. Example 4. Okay. Sorry about that. This is a parabola, the parent function. This is a parabola. In a parabola, they look like smiley faces. Like that. That's what a parabola looks like, okay? Because we're going to square numbers, okay? So first of all, for our parent function, okay, we're going to square numbers. 0 squared is 0, okay? And I'll put that in there. 0 squared is 0. 1 squared, ready? 1 squared is 1. 2 squared, I go 2. 2 squared, what's 2 squared? Well, 4. 1, 2, 3, 4. 3 squared is 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just kind of estimate where it is. And 4 squared, 16 is off the graph, okay? Now, remember, a negative times a negative is a positive. So negative 1 squared is a positive 1. A negative 2 squared, right? Go negative 2 squared. What's negative 2 times negative 2? Positive 4. 1, 2, 3, 4. 1, 2, 3, negative 3. 1, 2, negative 3. Negative 3 squared is positive 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is up here, which is estimate where it is. So this is what our parent function of a parabola looks like. And we did a lot of this in geometry. I don't know if you guys remember it. Hopefully, maybe not. Okay. So let's take this. Let's make a change. So let's take our x squared, which is our parent function. Because it has a negative in front of here, we're going to make it upside down. Because this negative is going to be upside down. Okay? Because of the negative. So any y values just become negative. Any y values become negative. And then we're going to take it up 4. Okay? So we're going to take this graph, our parent function. We're going to get up 1, 2, 3, 4. Okay? And then we're going to make it upside down. So it's going to have 1, 1, 2. 2 squared is 1, 2, 3, 4. 3 squared is 1, 2, 3, 4. 5, 6, 7, 8, 9. And of course, we'll do the same thing. Negative 1 squared is 1. Negative 2 squared is 4. But upside down, 1, 2, 3, 4. Negative 3 squared is 9. Positive 9, we're going down, right? We're going down because of the negative down. We'll go down to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Okay. So description. Let's use mathematical words. Here's what we did. Okay? Here's what we did. So what we did is we did a vertical shift, vertical shift up 4, and then we did a reflection over the x-axis. Okay? Now, there's going to be homework, and the homework you're going to have to show me in Canvas. You're going to do the homework on your workbook. And today's homework is going to be found, I'll put this in Canvas as well, on page 26, okay? So page 26 and page 27. I want you to do the whole thing. I want you to do 1 through 12. So page 26, I want you to do 1 through 27. All. Show your work. Do all the graphs. If you have any questions is all you can. Email me, and I can help you. I can even set up little mini Zoom lessons, or I can just text you, okay? So, there it is. Yeah, it's tough, but you guys are going to have to do this. This is going to be a tough way to learn, but you can do this. I have faith in you, okay? So, that's all I have for today. Please get this assignment done.